Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I would like to thank you for the ESChE committee and participant for conference these things. So I would like to presentation about the title Performance Compression of Residential Air Conditioning System with Eco-Friendly Refrigerants. And then the firstly, this my abstracts. The first is my favor investigate the performance of residential air conditioning system using three refrigerants. Some like this R32, R410A, and R407C. And then this study aims to compare different refrigerants to improve the performance of the RAC system. And then I'm using the comparative method of refrigerant performance in the RAC system. And then the results I'm compare the result is RT2, R4 10A, and R4 07C. And then the result R32 has been proven to high bit better COP and cooling capacity for this thing. And then this my introduction, this my paper. And this based on the performance of refrigerant in refrigerant systems. I'm using the eco-friendly refrigerant investigation R32, R410A, and R407C. Based on the Montreal Protocol, uh, all refrigerants GWP acceptable for Montreal Protocol. And then based on the literature review or reference, PP lubricants is compatible with R32, R410A, and R407C. And then this problem my statement based on the performance refrigerant in a refrigerant system, the result COP R32 with another compare with another refrigerants, COP R32 is the best for these things. But however, the comparative study of system performance for R32, R410A, and R407C in the RAC system was not found in the reference. And then significant of my study, there are two. The first comparison of refrigerants, namely R32, R410A, and R407C. And then second, performance comparison of residential air conditioning system with eco-friendly refrigerants. And objective of my study, there are two. The first, performance comparison of refrigerant in the RAC system, and second, the comparison of compressor work, COP, and cooling capacity was the main objective of this my study. Scope of my study is represents from 350 until 450 grams with compressor speed of 3000 RPMs. And second, investigation of refrigerant effect, compressor work, COP, and cooling capacity for this experimental this thing. And then material. These materials for the R32, R410A, and R407C. These are chemical formula, molar mass, critical temperature, critical pressure. And material method for the lubricants, some like this dynamic viscosity, because this I'm using the PP lubricants. This is dynamic viscosity index, for point, plus point, and density. And then experimental setup. This uh, figure one, this mass flow rates, this collect that this data logger, and this collect data, and then some like this thumbnail is some like this point tens is indoor system, and then this 6 points is outdoor system. Is in this is pressure jets, and then this is refrigerants, and then this indicator of the temperature, some like this humidity. And then uncertainty measurements, some like this pressure gauge, thermocouple type. Then this is a claim on mass flow rate. This measure ranks and uncertainty this value. And experimental procedure. This some like this formula, all formula, some like this formula one equation based on 1, 2, 3, and 4. for this cooling capacity, COP, compressor work, and refrigerant effect. But for this thing, I have the following assumptions should be considered. Some like this: the pH diagram shows ideal conditions. The condition enthalpy and evaporator inlet enthalpy, that's 5, some like a 6, are due to isentropic expansion in the capillary tube, and the insulator or heat transfer in the 5 connection to the environment can be neglected. This figure 2 is experimental preparations. And experimental procedure, this pH diagram of R32, and then pH diagram of R107A, and then this pH diagram for the 4R407C. And result and these questions, this figure 4 of refrigerant effect with various refrigerant at different refrigerant charge. This figure show that the refrigerant charge increase and refrigerant effect decrease. And we know that this based on the figure these things, R407C is uh, decrease with compare another refrigerants. Some like this figure 4, this refrigerants increase, compressor work decrease. And then we know that this based on the figure 5 is a refrigerant R407C is decrease compared with another refrigerants. However, based on the evaluation, COP is some like vice versa. Because the result, the R32 is the best for COP. And we know that this refrigerant has increased when the refrigerant has increased and COP increase also. And then the results show the COP for the R32 is the best with another refrigerants. And then some like this the trends figure 6 similar for uh trend figure 7. Why? Because when the refrigerant charge increase, the cooling capacity increase also. And then we know that the evaluation for the cooling capacity R32 the best with another compare another refrigerants. And the conclusions, the first is compressor work and refrigerant effect decrease when the refrigerant charge was increased. And then second, COP and cooling capacity increase with increasing refrigerant charge. And the third, R32 produce COP of 5.1 increase by 30.84% and 14.61% compared to R410A at R407C. And the last, the cooling capacity of R32 is higher than that of R410A with average increase of 86.31%, while R410A is better than R407C with an average increase of 48.91%. And my presentation finished, so I will let thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.